Afternoon, evening, everyone. It's great to see so many of you coming and joining us for today's talk on the Northwest Passage. For those of you who have attended one of our armchair travel events before, you'll recognise me. But for those who this is your first event, I'll introduce myself. I'm Claire Baxter, the Alumni Engagement Coordinator, who is responsible for running the travel programme here in Cambridge. So if anyone has any general questions regarding the programme, please use the chat function to contact me during the talk. For today's talk, we welcome two speakers, Dr. Owen Weller and also Professor Marc St-Onge. I hope I said that right. I'd like to thank you both for giving up a little of your time today to join us, especially as it started term here in Cambridge tomorrow. I would also like to thank and welcome Matthew James from Adventure Canada, who is jointly hosting our event today. Adventure Canada is our newest tour operator and will be running our Northwest Passage expedition in August next year, fingers crossed. And on that note, I would like to hand over to Matthew James.
All right, thank you so much, Claire. Before I get started, I just want to do a big thank you to you and everybody at the University of Cambridge. You've done so much to put this all together, and I'm really excited to be partnered with you. And yes, very hopeful for the program in 2022. So give me just a moment here. I would love to share a little bit of information about Adventure Canada and prepared a short little presentation. So as mentioned, my name is MJ Swan. I am an expedition leader with Adventure Canada. And what I'd like to do is not speak specifically about the program, the Northwest Passage, the destination. I'll leave that to Owen and Marc. But what I would like to talk about is the company itself and what we represent as a tour operator. So we're a Canadian company that specializes in expedition cruises. We were established in 1987, so we've been running tours to the Canadian Arctic and the Northwest Passage for over 30 years. So we operate expeditions all over the planet that combine a curiosity for different cultures with a passion for exploration. We engage, entertain, and educate by connecting people to each other and to the land through innovative travel experiences. We embark on these journeys because we believe in the transformative power of nature. One of the key differences between Adventure Canada and other expedition companies is we are family owned and operated in every sense of the term. Pictured here is my sister Cedar Swan on the left in the white sweater. And then Matthew Sr., my father, is in the middle holding his Lifetime Achievement Award that he received from the Industry Association of Canada. To the right of Matthew is my second sister, Alana Swan, who is our director of product. And finally, I'm on the right doing my best to look natural in a suit. I'm much more comfortable up in the Arctic than I am at award ceremonies. So I was doing my best to fit in on this particular day. So I'm extremely proud to work alongside both of my sisters and my father and all of my coworkers each and every day. I wouldn't change it for anything, even in the most challenging of times. I'm sure you can imagine it's been very difficult for the tourism industry, as it is for many industries these days. So our ship has often been described as a floating university. Our expedition staff are handpicked for each one of our itineraries, and the Northwest Passage is not different. We do not hire general guides. Instead, we hire specialists based on their knowledge in the specific region in which we're traveling to. Each of our staff will supply a never-ending stream of concentrated information about the Northwest Passage throughout our voyage. And they're always available for you to ask questions and chat about your particular interests. Much of the learning takes place on land excursions, but our onboard programming also offers a wide variety of lectures, workshops, and events. Education is a big part of Adventure Canada's mission. It is important to us that our passengers can learn and understand the destination we are visiting. Whereas most polar expeditions of this kind have a crew to passenger ratio of 10, 15, or 20 to 1, our expeditions on the Ocean Endeavour have an expedition staff member for every 7 passengers. This delivers a much greater personal touch. We love small group experiences where you can spend ample amount of time with our leaders to ensure that you get the most out of your trip. Travel is not just about new places. It's also about the friendships that you forge along the way. Our travelers come from all walks of life, and it's their shared attitude that unites them. They're curious, open-minded, love to learn, and very interested in protecting the planet, just like Adventure Canada is. One of the reasons I'm so proud to work at Adventure Canada is our regenerative tourism plan. We work towards a positive future for our planet, and we're undertaking several initiatives to leave the places we touch and the world in a better place. The Arctic is one of the last great wildernesses on the planet, so we put a lot of care into ensuring we leave only footprints behind on our expeditions. We're reimagining business practices that are not business as usual. Instead, we're looking at innovative ways to run our operation, support our partners, protect the natural world, and value people. We believe we can be the company that does expedition cruising the best, but we can also be the company that does it for the best reasons. So I'm going to leave it there. I'm going to hand it over to Owen and Mark, and they'll take it and run with it from here. But I would really like to see you in the Northwest Passage with us in 2022. And thank you so much for joining us today.
Great, thank you very much, Matthew, and also to Claire for setting this event up. And thanks to everyone for joining us. So a sort of virtual hello to all 500 odd of you. And thanks for joining Mark and I as we now talk to you about Into the Northwest Passage, 4 billion years of Earth history. So this talk is going to comprise 2 parts. So first, I'm going to set the scene. I'm going to say a few words about what the Northwest Passage is and the trip that Mark and I will be joining next year. And then I'm going to say some words on the geological timescale, and that's to contextualize this enormous number you've got here, 4 billion years. And then finally, I'm going to finish with a few words on how we conduct scientific research in the Arctic, because that's the reason that Mark and I generally travel up into this part of the world. I'll then hand you over to Mark, and he's going to give you a whistle-stop tour through the Northwest Passage, which is going to focus on a lesser appreciated feature, its geological archive, which hosts this amazing 4 billion years of history that you're going to learn about today. And he'll also show you lots of photos of the unique flora, fauna, and culture of the region. So we really hope you enjoy the talk. It's going to take about 30 to 35 minutes, and we look forward to any questions or comments you have at the end. So to start, what is the Northwest Passage? So to understand this, first a few words about the Arctic region. So pictured here is a circumpolar Arctic map with the North Pole shown as a red dot. And just to get your eye in a counterclockwise sense, around the North Pole, we have Greenland, Iceland, the northern tip of the UK, Norway, Sweden, Finland, Russia, Alaska, and finally Arctic Canada. Now, it may actually surprise you to learn that Arctic has several definitions. So one definition is everywhere north of 60 degrees latitude, which is shown here as a dashed blue line. And by this definition, the UK just makes it onto the map, as it were, courtesy of the Shetland Islands when they're shown in the correct map location. So a stricter and much more commonly used definition of the Arctic is everywhere within the Arctic Circle, which is shown here as a solid blue line and located at around 66 degrees north. And this marks the latitude at which the sun doesn't set in the summer solstice and doesn't rise at the winter solstice. So a third definition of the Arctic, and hopefully you can just about see this, there's a wiggly sort of maroon line here. And this marks that it's 10 degrees Celsius July isotherm. So everywhere within this region has an average temperature during the month of July less than 10 degrees Celsius. And this is also something of a proxy for the tree line. So as well as the term Arctic, the term Northwest Passage also has some subtlety, as it's not any one set route, but rather it's any route that takes you from the Atlantic to the Pacific in a sea passage through the Canadian Arctic archipelago. And the Northwest Passage is somewhat fabled due to a very long history of heroic but failed attempts to find this passage, and Mark's going to touch upon some of these later. But rest assured, as you've just seen, we're in the very safe and experienced hands of Adventure Canada when we visit there next summer. So specifically, Mark and I are going to be joining this tour called Into the Northwest Passage. It's going to be occurring in late August, early September 2022, and it's going to last for 17 nights. And we're going to travel or traverse the Northwest Passage. We're going to start in Kangerlussuaq on the west coast of Greenland, and then we're going to travel west around the northern tip of Baffin Island and end up in a place called Kugluktuk in Nunavut in the west. So the tagline for this trip, and indeed this talk today, is 4 billion years of Earth history. But without any context, this number is hard to imagine, let alone fathom. So to provide some context, here we have the geological timescale, which I would suggest is actually one of the most important contributions that geology has made to society, as it gives us an absolute reference frame. This is a rather complicated picture here, and it shows different hierarchies and different ways that geologists split up time into different time intervals, with each interval based on some kind of observed change in the climate or fauna based on the rock record. But what's important here are the numbers. So these numbers represent the ages in million years ago of time, from the present day all the way back to the beginning of the Earth, 4,560 million years ago. So straight away you can see that in seeing 4 billion years of Earth history on the Northwest Passage, we're seeing a fair window into nearly all of Earth history, as 4 billion is also 4,000 million shown here. But this is still a very complex diagram. You probably still don't have a feel for these ages, particularly as this scale is highly nonlinear. So to help you digest geological time and appreciate its enormity, here is now geological time mapped onto something much more familiar, the 24-hour clock. And I've just shown the 4 major divisions or eons of geological time, which are labeled here the Hadean, the Archaean, the Proterozoic, and the Phanerozoic eon. So if you do this maths, if you take the 4,560 million years of Earth history and you split it up into 24 hours, then 1 minute becomes 3 million years and 1 second becomes 50,000 years. So now when we say that on the Northwest Passage, you'll see 4 billion years or 4,000 million years of Earth history, what we're actually saying is you're going to see from 2:57 in the morning of this sort of Earth day. And you needn't feel shortchanged. You're not going to see the first 3 hours of the Earth day, because in fact, almost nothing exists from this time period. And that's why it's called the Hadean, named after the Greek underworld. And it's sort of meant to be evocative of this sort of fiery, inhospitable place. And almost nothing exists from this time period. And in fact, the oldest rocks in the world come from Arctic Canada. And so you're going to see the best and the longest time interval or time slice of geology anywhere in the world. So Mark's going to show you some lovely images of rocks which span from the Archaean through into the Proterozoic, with the division here marked at 2.5 billion years ago, or 10:30 in the morning when there's a big change in atmospheric oxygen. And then he'll also show you rocks spanning into the Phanerozoic. And this major division here is around 500 million years ago, or around 9 p.m. And this is when, you might have heard of this term, the Cambrian explosion. This is when fossils start becoming ubiquitous in the rock record because animals evolve sort of hard parts that can be fossilized. So for further context, dinosaurs went extinct 21 minutes ago, and modern humans entered the scene a mere 4 seconds before midnight. So throughout this talk, when Mark and I give you time periods, we'll quote both the absolute geological time, but we'll also give you the reference to the 24-hour clock just to help you contextualize this time, as I appreciate these are sort of big numbers without context. So finally, I'd just like to say a few words about the logistics of conducting scientific research in the Arctic, because this is the reason that Mark, pictured here, and myself typically travel to the region. So the first thing you need to do is sort of assemble yourself a field crew. And my tip here is that you want roughly more than 10 people, such that you can warrant having your own camp chef. And typically we travel to the fields using a twin otter style of aircraft. And that's because their low pressure tires are absolutely fantastic for landing on almost any terrain. So next, you want to set up a field camp. And we generally locate our camps on geographic features called eskers. So eskers form in subglacial melt streams. And then when the glaciers retreat, they leave behind these long, sandy features, such as shown here. And these are great for a couple of reasons. So one, these long, sandy strips are great for landings for the twin otters. And also the sand means it's good for drainage, so good for camping on because it's not too boggy. And they're typically located next to fast flowing water. And these camps, we set them up for 6 to 8 weeks. And that's because there's a narrow window in the summer when there's no snow on the ground. You can see when the snow melts, there's fantastic exposure of the bedrock. So you can see all of the rocks poking out here. So it really is a geological paradise. So a typical day in the field involves a very strict 8 a.m. departure from camp in a helicopter. And we have to be quite strict and impose these timings because of the 24-hour daylight. So the helicopter will take us in pairs to some predefined location in the field where we're dropped off. And it's quite something when the helicopter leaves the scene and you're left sort of alone in the tundra with just the mosquitoes for company. And typically in pairs, we then walk 8 to 10 kilometers over the terrain, again in a predefined route. So we're crossing geological features of interest identified from satellite imagery. And along the way, we make observations. We look at the rock types, we measure things in the rocks, we collect samples, and we take photographs. So here's me pictured in the field. You can see some of our tools. I've got a hammer here, and I've also got in my hands a compass clinometer. And at the moment, I'm taking a measurement of something about the rock, its orientation. And all of this data gets put into a field computer, And then it's synthesized with various airborne data sets, so sort of airborne photo imagery and also regional gravity data sets. And all of this data together helps us to build up a 2- and 3-dimensional picture of the rocks, which is then synthesized and published as modern advanced geological maps. So this is just one snippet of one of the many maps that we've published, with the different colors here representing different rock types and the different symbols telling you about how those rocks are contorted in 3 dimensions. And the other symbols tell you about how the different rock types are juxtaposed. So these maps are published in both English and French. And also I've been very proud to be part of a new initiative by the Geological Survey of Canada to publish the world's first maps in Inuktitut, which is the language of the Inuit and this lovely Slavic language here. So these maps are also, an important part of them is incorporating traditional knowledge. So this is both, before we do any mapping, so here's Marc pictured with the elders in the Cape Dorset community of Southwest Baffin Island. So we seek their permissions to operate and do field work on their lands. And we also take note of their local names. So for example, they might have a name like the place where the white rock flows, and that might tell us, oh, there's marble likely in the region, or the place where we can carve the rocks, and that typically tells us there's a rock type called serpentine, which is very soft. So incorporating traditional knowledge throughout the process is very important. What's also important is training Inuit students, and this is typically done sort of on the job in the field. So we typically paired sort of a geologist with an Inuit student, and we travel as pairs and teach them about the geology along the route. But this transfer of knowledge is 2 ways, as we also learn so much about the land from their perspective. And some of the most interesting days in the field I've had have been partnered with Inuit students. So the second main product from all of the work that we do is all of the follow-up analytical work we do. And this is sort of the scientific outputs that come after we've done the mapping. And I often get asked, how do you analyze a rock? So just a quick guide here before I hand you over to Marc. So the first thing you do is you take a rock and you then, with a diamond saw, you cut out a matchbox-sized piece of your rock, stick it onto a microscope slide, and then grind that sample down to 30 microns thickness. And then you're left with this little chip here, it's called a thin section. It transmits light and is good for microscopy. You can then put this thin section in lots of different machines. So this is putting it into a machine in Cambridge called a scanning electron microscope, where we can do further imaging and characterization of the minerals. We can put it into something called an electron probe microanalyzer, and that allows us to measure the compositions of all the different minerals in the rock. And with this information, we can then build up thermodynamic models of the rock. So we can describe how the rock assemblage or the minerals in this rock will change as a function of pressure and temperature. And by comparing the observed minerals to these models, we can say something about the formation conditions of that rock to build up this bigger picture of the rock's history. Finally, we can also put our rock into these very large machines here. So this one's in Ottawa. It's called a sensitive high-resolution ion microprobe, or the much funner SHRIMP for short. And this works by blasting a sample with oxygen ions. That sputters some sample, which is then focused through into the collector. And we can very precisely measure things like uranium and lead ratios, such that we can calculate the age of rocks, such as I showed you earlier in the geological timescale. So ultimately, we synthesize all of this information into sort of coherent articles. So here's just a few that Marc and I have published the last few years. And it may interest you to know that actually the Canadian Arctic has been fundamental to the most important theory in the earth sciences, that of plate tectonics. So just in my final slide here, I'll just highlight one of these advances. So one really interesting thing that's emerged is, and just here's a sort of map of North America. Here's Greenland again, here's Baffin Island. And shown here in blue is this ancient mountain belt. So this ancient mountain belt is called the Trans-Hudson Mountains, and these formed 1800 million years ago, or 2:37 in the afternoon. And these ancient mountains formed from the collision of 2 plates. So this pink plate here collided with this green plate here to form these mountains. And through the research that we've done, we've shown that the Trans-Hudson, these 1.8 billion year old mountains, look exactly like the Himalayan mountains, which formed 50 million years ago, or 16 minutes to midnight. So this is the same scale and same orientation of, same projection of map. And you can see that the Himalayas formed from the collision of India with Asia. And the comparison goes much further than this map view, as in detail, sort of the crustal and plate scale structures are the same, and the magmatic and metamorphic rock record are the same. And these are the kind of stories that we can tell you all about when we're aboard the ship during the Northwest Passage traverse. So speaking of that, I'll now hand you over to Marc, and he's going to show you some pictures and tell you all about what we'll see during Northwest Passage. Thank you.
Thank you very much, Owen, and good evening, everyone. Armed with this newly acquired knowledge of how Arctic geological fieldwork is conducted and what it can lead to, what can participants expect to see, geologically speaking, on a transit of the Northwest Passage from Kangerlussuaq, Greenland to Kugluktuk, Nunavut? The short answer to that question is nothing less than 4 billion years of Earth history, as mentioned by Owen, ranging from some of the oldest rocks in the world to some of the youngest. In chronological order then, starting with the ancient rocks of the Archaean Eon, a period of Earth history that lasted from 4.0 to 2.5 billion years ago, or if we make use of the 24-hour Earth clock introduced by Owen, equates with a 2:57 a.m. start and a 10:31 a.m. finish. A transit of the Northwest Passage offers access to and stunning views of kilometer-scale cliffs of the Earth's earliest formed crust, literally the foundation for all continents and everything that followed, and comprising deeply seated, well-layered magmatic rocks that cooled and crystallized in the elevated thermal regime associated with the Archaean. The word Archaean being derived from ancient Greek and meaning beginning. At the end of the Archaean Eon and start of the next time slice of Earth history, which is called the Paleoproterozoic, and lasted from 2.5 to 1.6 billion years ago, or on the 24-hour Earth clock from 10:31 a.m. to 15:35 p.m., the way the Earth evolved changed dramatically. Continents, in the modern sense of the word, saw the light of day. Not the same 6 continents that we have today, but earlier versions amongst others, and pertinent to our Northwest Passage trip, the core of the North American continent, which is called Laurentia. Continents separated by oceans, underlain by oceanic crust, and continents mantled or rimmed by continental margin sedimentary rock formations, the one shown on the slide being from the Western Canadian Arctic. As befitting the Paleoproterozoic, a term combining 3 forms of ancient Greek and meaning ancient earlier life, a key feature of continental margins of this era are indeed some of the earliest traces of life itself, namely circular, dinner plate size, finely layered brown mounds called stromatolites, formed by bacterial colonies of blue-green algae living on the margins of warm, shallow seas and dated at 1.9 billion years old in Arctic Canada. Trace fossils that can be examined in glorious 3 dimensions in dolomitic rock formations of the Paleoproterozoic era. The ones shown on the screen being from a locality called Port Epworth on the south shore of Coronation Gulf in the Western Canadian Arctic. Trace fossils that were largely responsible for the Great Oxidation Event and the rapid buildup of oxygen in both the oceans and the atmosphere during the Paleoproterozoic era. And trace fossils that also served as an inspiration for a murder mystery short story by Canadian author Margaret Atwood called Stone Mattress. The title of the story derived from the English translation of the Greek word stromatolite. Inspiration that came to Margaret Atwood during an earlier rendition of the Northwest Passage trip by Adventure Canada, updated trip that we are proposing to you, the alumni of Cambridge, in 2022. With the formation of continents during the Paleoproterozoic era comes the opening and the closing of oceanic basins and the collision of continental land masses in a process called plate tectonics, which Owen alluded to. Consequently, the rock record of the Arctic includes planet Earth's first collision-derived Himalayan scale mountain belt with its deformed and inclined strata, as seen here in West Greenland, extending no less than 3,000 kilometers across North America, from Greenland and the eastern Canadian Arctic through Hudson Bay, Western Canada, and into the Midwest US. A rock record formed 1.83 billion years ago that we will have many opportunities to examine closely in outcrop on our hands and knees and read with the aid of a hand lens or a loupe as one would read the pages of a book. By the end of the Proterozoic eon, the continents had reorganized themselves through the process of plate tectonics, not once, but twice, into Pangea-type supercontinent configurations. A first time 1.8 billion years ago into a supercontinent called Nuna, meaning the land, in Inuktitut, and a second time 1.0 billion years ago into a supercontinent called Rodinia, meaning fatherland in Russian. All of this continental tectonic activity and reorganization of continents was then followed by the next time slice of Earth history, the Paleozoic Era, which lasted from 541 to 252 million years ago, and on the 24-hour Earth clock from 21:09 p.m. to 22:40 p.m. A period of time that saw the accumulation directly on top of the dark-colored, folded and faulted rocks of the Proterozoic eon, here seen outcropping behind a classic red and white Canadian Coast Guard vessel, of overlying light-colored, cliff-forming fossiliferous Paleozoic strata, comprising flat-lying, layer cake, uniform and extensive rock formations of sandstone, dullstone, and limestone, deposited along the northern margin of Laurentia in warm, shallow equatorial seas. The equatorial position for accumulation of these strata, pinned or constrained by rich assemblages of warm water, shelly fauna, including brachiopods and crinoids, as well as solitary, colonial, and branching coral. Leaping forward to the Paleocene Epoch, which lasted from 66 to 56 million years ago, and on the 24-hour Earth clock from 23:39 p.m. to 23:52 p.m., this epoch witnessed the opening of Davis Strait and the separation of Greenland from the eastern Canadian Arctic, a geological event recorded in the form of kilometer-scale cliffs of massive and columnar volcanic basalt flows, very similar in terms of age, morphology, and significance to the erstwhile well-known basalt flows that comprise the Giant's Causeway in northeastern Northern Ireland. And at the younger end of the geological timescale, the Arctic's geological record includes some of the most dramatic evidence for the series of glacial and interglacial periods that characterize the Earth's most recent time slice, the Quaternary, which lasted from 2.58 million years ago to the present, and on the 24-hour Earth clock from 23 hours, 59 minutes, 11 seconds p.m. to pumpkin hour, with the last glacial maximum, the maximum extent of glacial ice in North America and Greenland, having occurred a scant 16,000 years ago, and remnant ice from the last ice age flowing down today from the Greenlandic inland ice and the various ice caps of eastern Baffin Island, Devon Island, and Ellesmere Island in Arctic Canada, as tentacular glacial tongues, leaving in their wake, when the glacial ice recedes, diagnostic morphological features such as ice-carved U-shaped valleys, ice-choked marine fjords. Note the people for scale at the bottom of the slide. Active and dramatic, not to mention noisy, a bit like a 21-gun salute, glacier calving fronts, and languid yet majestic icebergs, 9/10 of which remain submerged, that is, until one decides to roll over, which has been seen on previous trips. Now, with all that said, Owen and I have no illusions. Few people ever join this type of trip primarily for the geology, in spite of the many reasons to do so, including the opportunity to examine no less than 4 billion years of Earth history in about 2 weeks. Nevertheless, in our experience, most people eventually come around to appreciating all that there is to learn from the unique rock record and ever-changing landscape of the Arctic. Rather, it would probably be closer to the mark to say that many people, most people, visit the Arctic first and foremost for its fauna, with Nanook, the iconic white polar bear and part of the Adventure Canada logo, likely being at the top of the bucket list, and for good reason. The polar bear is without a doubt a majestic marine mammal, superbly well adapted to the Arctic environment, with an adult male weighing approximately 450 kilos and able to sprint 40 kilometers an hour. Or perhaps it's the chance to see walruses sunning themselves on an ice floe. In this case, a mother and cub, with the adult walrus weighing no less than a ton, 1,000 kilos, and both males and females sporting a pair of debonair tusks. Perhaps it's the opportunity to see beluga, mink, or as shown here, humpback whales feeding on small crustaceans and fish, humpbacks that come in at a whopping 40 tons and measure up to 60 feet in length with tails up to 18 feet in width. Or perhaps it's just the chance to see a drove of Arctic hare with their shortened ears and coat of fur. More subtle, but equally beautiful, is the diminutive flora of the Northwest Passage, which ranges in species and color from the yellow heliotrope Arctic poppy to the lush seashore chamomile or wild chamomile, also known as sea mayweed, to plump berries, including blueberries, cloudberries, Arctic raspberries, or as shown here, black crowberries, to the bright yellow autumnal color of the Arctic dwarf willow. If history is more your thing, but perhaps not going back as far as the history of planet Earth, then a transit of the Northwest Passage has much to offer, including archaeological sites such as the one shown here, which features a Thule Eskimo stone house. The Thule people, or Proto-Inuit, being the ancestors to all modern Inuit, with the classic Thule period extending from the end of the 11th century to the end of the 14th century, and predating what is known as the Little Ice Age. Speaking of the Little Ice Age, which was a period of long, cold winters, short, cool summers that characterized the climate of the Northern Hemisphere between the end of the 14th century and the end of the 19th century, it was precisely then that first the English, then the British, then the American polar explorers ventured into Arctic Canada, beginning with Martin Frobisher and continuing with Henry Hudson, John Franklin, John Ross, John Rae, and Robert McClure, to name but a few. A transit of the Northwest Passage offers multiple opportunities to examine the vestiges of these expeditions, including the frozen graves of John Franklin's men on Beechey Island, the island of lost explorers. The stone cairn erected by Francis Leopold McClintock, or at least his men, in their 1858-1859 search for traces of the ill-fated Franklin expedition. Fort Ross on Somerset Island at the entrance to Bellow Strait, erected in 1937, and the Hudson Bay Company's last built fur trading post. Basically, ice conditions made it so difficult to reach Fort Ross that the company shut it down in 1948 after 2 employees received no communications nor supplies for 3 years. Dundas Harbor on the south side of Devon Island, built a century ago by the Royal Canadian Mounted Police as their northernmost outpost to fly the flag and, during the spring months, go on sovereignty patrols, informing anyone they encountered that they were on Canadian soil. But perhaps most uniquely and endearingly, the transit of the Northwest Passage provides multiple opportunities to meet, listen to, and learn from the people who actually call the Arctic their home, the Inuit and their elders, with their rich cultural history and their stories of endurance, kinship, travel, and community, and how they, too, are learning, as they always have, and continue to adapt to the opportunities and the pressures of the modern 21st century world, while retaining their customs, traditions, and language, both in Greenland and in Canada. To wrap up, the good news is that whatever aspect of travel interests you the most, be it geology or biology, archaeology or history, meeting new people and experiencing new cultures, or simply taking in unique Arctic places, landscapes, and phenomena, on a transit of the fabled Northwest Passage from Kangerlussuaq, Greenland, to Kugluktuk, Nunavut, with Owen and I, and the fine folk from Adventure Canada, you can have it all, including, depending on ice conditions, being escorted by Canadian Coast Guard icebreaker down McClintock Channel, a luxury the Franklin expedition didn't have, which undoubtedly led to its demise back in 1845. Thank you, merci, nakurmiik, with special thanks to the Geological Survey of Canada for having funded 5 decades of fieldwork in the Arctic, with some support from the NERC Arctic Office for Owen. To Claire and the Cambridge Alumni Association for hosting and facilitating this presentation. To our partners in Nunavut for the partnerships and collaborations over the years, and to Matthew James and Adventure Canada for enabling responsible, sustainable travel to this unique part of the world. As has been said by many who have traveled north of the Arctic Circle, there's no place quite like it anywhere else in the world. And finally, many thanks to our good friend Dennis Minty, photographer extraordinaire with Adventure Canada, for the use of some of his remarkable photographs in this presentation. Thank you.
Wonderful. Thank you so much for that, gentlemen. Very informative session. I really enjoyed that. Thank you for sharing your wealth of knowledge with myself and everybody else that's tuning in today. So for those of you that have not already done so, now's the opportunity to enter any questions that you might have for myself or Mark or Owen. You can use the question and answer feature in your Zoom platform to ask any questions. You could also use the chat feature if you're more comfortable. Throughout the presentation, we did have a number of questions come through. So I'll just propose a couple of those now. The first one was a question about the tour itself and how many people would be on board an Adventure Canada expedition cruise to the Arctic. So the ship that we operate on is called the Ocean Endeavour. It is 198 passengers with just over 100 crew. So we're just under 300 total people on board the Ocean Endeavour. Now the ship itself can actually host up to 450, but we decided that that is too many for this type of travel experience, that smaller numbers are better for this type of expedition. So we limit the amount of guests that we bring on board our tours. So it's capped at 198 travelers on the Ocean Endeavour sailing through the Northwest Passage. There was a question about the slides being available for review afterwards. I do know that this presentation has been recorded and it will be hosted for your viewing pleasure afterwards if you want to relive the presentation, or maybe you want to share it with some friends or colleagues. You can do so with that recording that will be shared with you post-presentation. Also, if you're interested in obtaining those slides, we'll connect with Owen and Mark to see what might be possible. Okay, here's another really good question. So at the start point of your proposed trip, there are some spectacular alkaline rock assemblages. Does the trip provide for some viewing of these? Maybe Mark or Owen, do you want to jump on that one?
Well, if the alkaline rocks referenced are those of southern Greenland, no, the trip would start north of there. But we see equivalent rocks elsewhere, though.
Fantastic. Here's another one that I'll propose to the both of you. You mentioned geological time is a useful absolute scale. Can you elaborate on that?
Yeah, sure, I can take that one. I guess by that I meant sort of early on in the history of our subject, a great breakthrough was just the concept that, small scale incremental processes that you see at the present day, like, rivers meandering down or an earthquake moving the ground by a few centimeters or a meter. The concept that could build up over time to produce geological features like mountains or great canyons. But for a long time, there was a big question mark as how long those processes would take. But through the pioneering discoveries of physicists, sort of like Rutherford and Curie at the early part of the 20th century, and the discovery of radioactivity, which certainly we're indebted to that, we're able to put sort of numbers on these processes. And I guess I should be a little bit careful sort of for any pedants out there with the term absolute. So obviously they're only as good as sort of, our calibrations. And to a certain decimal point, these numbers change as certain references change through time. But we're never going to change, the sort of approximate times that we've given you in this presentation. So I think it just allows you to sort of really put a finger on, did that process take 1 million or 1 billion years or 100,000 years? And ultimately put that in the reference frame of the Earth being about 4.5 billion years old.
Thanks for that. Okay, here's another question. It was specific to a slide that was at the very early start of the presentation. There was a lot of white rock. And the question is, was that quartzite or marble? Do you happen to know the second slide, Owen?
Yeah, so I'll just share my screen here just to bring that. So I think you probably mean one of these two slides. So what you're looking at here, these Archaean rocks, So very typically, this is a general suite of rocks we call orthogneisses, and that just means they're metamorphosed igneous rocks, and they typically have a broadly granitic composition. So these sort of lighter parts here are probably a kind of a granite called a tonalite, which is mainly comprised of two minerals, so quartz and plagioclase. But as Mark and I will show you on the trip, you can do quite a lot from the ship, but it's great to be able to sort of get onto the outcrop and get with a hand lens, and we can then identify the different minerals and sort of give you an absolute rock definition. But you're probably looking, broadly speaking, at a variety of granite called a tonalite there, unless Mark has anything further to elaborate.
Mark, did you want to add on that, or are you happy with Owen's answer?
Yeah, no, I think Owen answered that quite well. So we can go to the next question.
Sure, okay. So there's a couple of questions pertaining to the specifics of the tour itself. So I think I'll tackle some of these, and I'll kind of combine them together because they're overlapping a little bit. So one of the questions is, if taking the tour, what opportunity is there for strenuous exercise? So looking to do some calorie burning. So I can talk about that. And then also the question that kind of overlaps is how much of each day is spent ashore if joining the expedition. So on a daily basis, we try to get off the vessel, weather permitting, as much as possible. I like to describe each of the shore landings as anywhere from 4 to 8 hours in duration. And sometimes we get to do 2 landings in a day if luck and weather be on our side. So typical morning, we get up bright and early, get our coffee or breakfast. We would head ashore for a variety of different excursions, whether it's going off hiking, going bird watching, exploring the Arctic tundra, botany, maybe doing a little bit of geology, sourcing as well. So you'll get a variety of different activities that you can choose from. We would return to the vessel for lunch, and then if possible, we would go back ashore after lunch before returning for the final portion of the day, a meal spent on board for dinner, and then some light evening entertainment. And then, believe it or not, mixed in between there is a number of lectures and presentations and workshops as well. So it doesn't really feel like a vacation because there is so much going on. You don't get very much downtime. But thank you for those questions. Okay, here's another good one. Do you have archaeology heritage experts with you on the trips? And are you recording potentially new discoveries as you go? Mark, would you be able to answer that one?
Yes, the answer is yes and yes. As there are geologists and biologists and historians on board, there are also archaeologists, and they serve 2 useful purposes. One is to obviously document and explain what we see when we make shore excursions, as Matthew James was saying. And also, new discoveries do occur on these trips because some of the landings are new for everyone involved. Some are landings in places that haven't been seen in a long time, and that includes recording new geological features or new archaeological sites as well. And when that occurs, yes, there's a process where everything is recorded, photographed, locations are then forwarded to the appropriate agencies in, well, Canada or Greenland, depending where one might be.
Agree with that. Very well put. Thanks for sharing. Here's another good question on the scientific geological expeditions. Are the geologists at risk from polar bears?
Do you want to tackle that one, Owen, or do you want me to?
Well, I guess Mark and I are both still here. Mark's got a much longer take on this. That was certainly, so I joined the Geological Survey about 5 years ago, and that was certainly the #1 question that I asked Mark. But he reassured me that in the whole history of the field work that they've done up there, then there's never been any serious confrontation with a polar bear. And we have lots of training in sort of reading any behaviors that we see. But ultimately, the polar bear, it's called Ursus maritimus. Like, it wants to be at sea, it wants to be eating off the sea ice. Whereas geologists, we want to be on land or up high. So we don't tend to cross paths too much. If we do cross paths, we have various protocols with which we follow. One of which can be to sort of call in a helicopter to leave them well alone. So we typically seek to just avoid interacting or meeting with them for sort of obvious reasons. But Mark, perhaps you can elaborate on any of that.
Well, once again, well said, Owen. I would just add that in addition to various safety protocols that we adhere to, we also traverse in pairs and carry shotguns if ever that were necessary as a last resort, but it's never happened. But we're prepared in any case. And otherwise, encounters do happen. I suppose one advantage of working in the Arctic is that often enough you can see well around you, 360 degrees. So it's a bit of a different environment than if we were working in the mountains, for example, where the line of sight would be much smaller. But nevertheless, the encounters do happen, and so far in the history of the Geological Survey of Canada, it's always ended well for both the geologist and the bear.
I'll just add two quick points that I've thought about. So one is early season. If you're a bit worried about polar bears, unfortunately, every little bit of snow on the ground, so when you're traversing over the horizon, can look like a polar bear. So I was a bit jumpy for the first day of my geology, but soon learned after that. And the second thing is in terms of them having nowhere to hide. I got a guide to the local flora of the Arctic when I first did my first field season. And on every page of this book to the sort of local shrubbery was a little mouse. And essentially, if the mouse was looking up, then the shrubbery they were talking about was bigger than the mouse. And if the mouse was looking down, it was smaller than the mouse. That gives you a feeling for the size of the average plant you encounter in the Arctic. So yeah, we're very well sighted when it comes to polar bears.
Yeah, most definitely. And I'd like to just add on to that from a tour perspective. We've been operating up in the Canadian Arctic in Greenland for 34 years now, and very thankful and happy to report that although there is polar bear encounters, with proper preparation and training, those encounters can be non-disruptive for both the travelers and the polar bears themselves. It's extremely important to not be disrupting the wildlife of the destination or disrupting anything in the destination. So we take very seriously proper preparation. We do extensive land searches before sending our guests ashore. And because of the amount of training and preparation that we do for each one of these expeditions, we found that you're always able to enjoy respectfully without disrupting any of the wildlife. And so we feel that that's really, really important, but it does mean that sometimes you have to change your plans. Mark, you know very well about this, that sometimes we have a extraordinary geological site that we want to go and visit, but there might be a mother polar bear and her cubs there, and for that reason we would stay away. We would find somewhere else to go off exploring. Okay, here's kind of an open-ended question, but I'll still propose it to see if either of you want to comment on it. So this question is, what about oil deposits, specifically in the Northwest Passage? Do you guys have any comments about oil deposits or oil-rich areas in the Arctic?
Shall I take that one, Owen? Yeah. So in terms of oil deposits, the classic Northwest Passage is much too narrow and is underlain by rocks that are too old to be to fit the petroleum window or to be of interest, I guess. You have to go to either the northern end of Davis Strait, Baffin Bay, which has great oil potential, or much further north to the Surger Basin, which is in the northern end of the Canadian Arctic archipelago, and that too has proven oil and gas reserves. But Other than crossing the Davis Strait, no, we're not in that type of geology for the bulk of the trip.
Okay. Here's a question about the Hudson range, the Trans-Hudson range. Is it visible on the surface, or is it all subsurface? That's the Trans-Hudson range.
The Trans-Hudson origin. Oh my goodness, it's definitely visible on the surface, which is why Owen and I work in the Arctic. The exposure is unparalleled. You can pick it up from satellite imagery. It's obvious, it's blindingly obvious in the field. So very much well exposed in Greenland and Arctic Canada as it treks or trends southwestward into Manitoba, Saskatchewan, and then the Midwest US. There the exposure drops off, and one needs to rely more on sort of geophysical parameters and remote sensing data to trace it southwest. But the part of it we'll see, incredibly obvious and stunningly beautiful.
Can I just add slightly to that? So when we're saying we're sort of seeing these ancient mountain belts, so obviously they have been ravaged by erosion, and we're looking at a structural level essentially below what you're seeing in the Himalayas at the present day. So there's not these sort of great, several kilometer high peaks there, but you're essentially, from the sort of the thermodynamic modeling that I mentioned, we know that we're looking at an exposure that is similar to maybe about 15 to 20 kilometers below the present day Himalayas. So it's almost as if you're taking like a slice through the earth at a section below the present day exposure. So that's why it's great. We can sort of imagine directly what is going on beneath the Himalayas and the Tibetan Plateau, and vice versa. We can look at the Himalayas and Tibetan Plateau to think about what processes were occurring in the Trans-Hudson when it was going on. So it's this amazing archive because of the level within the mountain that we're at due to this 1.8 billion years of erosion.
Mm-hmm. It seems like a number of our listeners have also had the pleasure of experiencing the Canadian Arctic and areas of the Northwest Passage. There is some comments that I would just like to share from some of the listeners. So one was time spent on Ellesmere Island back in 1989 doing some geological field work. They carried shotguns just in case there was any polar bears in and around to deter or even to protect themselves as necessary. But fortunately, that did not arise back in 1989 for this particular individual. But they did have some Arctic wolves visit the camp, and they found some of the food that they had in and around the camp. So that must have been a very exhilarating experience to be with the Arctic wolves. And then there was also a comment about being chased by muskox, which I can only imagine must have been absolutely frightening. Those are really interesting large animals and usually in a herd. And when one of them gets spooked, they all tend to go for a bit of a run at the same time. So I'm sure that must have been a pretty scary experience, to say the least. There's another question here about local food and getting to eat local food. Now, both of you have spent time in the north, so I'd love to hear maybe some of your thoughts about the foods that you got to try while being up in the north, doing your field research, and what you enjoyed, what you didn't enjoy. I'll just add from a tour component that we always have the opportunities to try country food and local food. So if you do decide to join us, there'll definitely be opportunities for that. But either Marc or Owen, do you have any personal stories that you might want to share about getting to try the local delicacies?
Well, I'll start and then Owen can chime in as well. Over the years, because as we explained, because a lot of our projects, geological projects, are partnered with the Inuit, these people know the land better than anyone else, and they also know where to fish and where to hunt. And they don't mind what we would call southern food, I guess, and the way we prepare it. But eventually, during the course of the field season, yeah, they'll gravitate back to the fish and the caribou specifically that they knew well, and we of course benefited from that opportunity and their experience. So a personal favorite of mine is caribou, and it can be roast or any cut of the caribou. It's incredibly flavorful. It's a very lean meat. It's absolutely delicious. And then Matthew, James, you know this as well, I guess, for Arctic char in terms of fish, nothing quite beats char. I think it's like salmon, but much less fatty, and incredibly flavorful. So yes, that's my vote in terms of country food.
Char is delicious. What about you, Owen? Did you get to try anything?
Well, yeah, I was going to bring up the fishing actually. Yeah, nothing really beats the fresh char. And because I guess the rivers are quite remote and no one's really fishing on some of the areas. Then at the end of some of the traverses, if they were sort of next to a good spot, then you can sort of finish the day waiting for the helicopter with a spot of fishing if you have the fishing license in hand, and then bring it back to the camp chef who might be able to prepare it for dinner. But you do have to be careful in that instance not to attract any wolves to your camp with some of the leftovers. Yeah, I've only really tried the char, but it's a better version of salmon. It's wonderful.
Well, there are so many questions. They still keep coming in. So gentlemen, I hope that you're still okay to go for a little while longer. I know we don't want to keep folks for too long, but I would love to still get some of these questions answered for our listeners. Okay, so how about this one? You talked about the research trips, relationships, and interactions with the Inuit. Could you share a bit more around this? How do you work together and learn from each other? So I'll just ask it one more time. You talked about the research trips, relationships, and interactions with the Inuit. Could you share a bit more on this? How do you work together and learn from each other?
Do you want to go ahead, Owen?
You've got a much longer history, I guess, working with them. I mean, from my perspective, I've done 4 or 5 expeditions now with the Geological Survey of Canada, and each time we've always involved Inuit students who are sort of researching some kind of geology or sort of Earth system style degree in the universities in the north. And as part of their program, they'll come on and they'll very much learn sort of on the job with us as we do the traverses. And by the end of the field season, they're fantastic with sort of manipulating and using sort of all the field tablets and all of the tools we have there, which can then go on and be helpful for sort of various jobs that they have, be it as sort of park rangers or anything else. There's also commonly, if we have a wildlife monitor in the camp, that'll typically be courtesy of a local Inuit guide who obviously has tremendous knowledge of the terrain, and certainly you feel much more comfortable at night when you go into your tent knowing that you're in the safe hands of a wildlife monitor. But Mark, do you have any other comments?
Yeah, I'll just add a bit to that. As Owen said, the main thing are the Inuit students, and they're correctly seen as the future of Nunavut. And like any student in earth sciences or geology, the more field training, the more field experience they get, the better they become as young geologists. And other than that, the interaction and the partnership with the Inuit communities, whichever is closest to the research project area, really begins well before the field work and the field season itself. It starts with consultation, which means presenting the proposed research project to community associations and groups and councils, town councils, hamlet councils, to make sure that they know what's being proposed, that they understand, and that they approve of what's being proposed. And that's where the partnership starts. It starts well before the field work. It continues during the field work with the hiring of Inuit students. And as Owen said, other personnel that can help with running of the field research camp itself. And then it continues afterwards with, as Owen said, the publication of the results, the geological maps, in the language that they use, Inuktitut. And it also involves summary presentations to the same people that were consulted before the start of the research project, the town councils, the hunters and trappers associations, so that they, as taxpayers like any other Canadian, understand where all this effort, this money, and this research, what it's brought. And yeah, so it's something that's worked well for, I'll say, decades now, and to everyone's benefit, the researchers and the people who live there.
Very well said. Okay, so we are, I think I would like to get one more question in, because I'm sure a lot of people are curious about this topic, but I don't want to drag it on too long. So we'll go with one more question, and it's kind of a two-part question. I'm pulling two different questions from two different individuals, but they overlap a little bit. So the big question is how is climate change affecting access to the Northwest Passage? And then the second part to that question, for how many years has the Northwest Passage been open to shipping? And during this time, has it been open every year? So why don't I start? I just want to share my perspective from being a tour operator and looking at it from a commercial tourism perspective. I've been very fortunate. My first tour to the Arctic was at a very young age, and I've been very lucky to get to return. Unfortunately, I didn't get to go in 2020, and I'm not going to get to go in 2021 for obvious reasons. But previous to that, it had been 15 years in a row that I had returned to the Canadian Arctic. From my personal experience, I could see year after year after year the changes that were happening in the ecosystem, the migration patterns of the marine wildlife, the behaviors of the polar bears were changing quite dramatically year after year, and just how the polar bears were interacting with each other, usually like to live a life of solidarity by themselves. I'm just seeing how they're adapting and finding food together, starting to hunt together as food sources become more difficult to find because of the receding sea ice and disappearing sea ice. Found that really interesting. And then it's very easy to put a visual on seeing the glaciers retreating as you go up to the same location year after year, and you can take that photograph and you can see how the glaciers are starting to recede, or not starting, but are receding and disappearing. So to me, it's very apparent that it's having a major effect. Also, the increase in amount of vessels that are now starting to explore this region as far as commercial tourism goes. We've seen a steady increase of different operators coming into the Canadian Arctic. When I first did my first season up in the Canadian Arctic, we saw 2 ships over the course of the 60 days that I was there. And now the last season that I was up there, you would probably see a ship every 3rd day or every 4th day. So it is an incredible change to see how many new vessels were coming into the region. But I would love to hear from both of you as well, because you have spent some time up there, and you must have different perspectives of how climate change is affecting access to the Northwest Passage, and in particular, the shipping routes.
Well, Matthew, James, I would just concur with what you've said. There's been an obvious change in the last few decades, basically, and whether it's the Northwest Passage and how it's opening up earlier and staying open longer, which doesn't preclude ice rafting in, though, as we all know, and still blocking access to parts of it. But the same evolution is apparent on land as well. In other words, the field seasons for geologists or biologists or anyone who does research in the Arctic, in a way, are becoming longer because the snow melts earlier in the the spring, and snowfalls tend to come in a bit later in the fall. So yeah, no, we see it with just the length of the field season, and there's no doubt which direction it's going in. Owen?
Sure, I actually saw there was another more general question about all the pictures having lots of sunshine and what the weather's sort of like, sort of the climate, the weather and the trips. So just a quick follow-up on that. The blue skies aren't actually that misleading. So they have these very stable high pressure systems that really stick around in the high Arctic over the summer. So they're fantastic to sort of visit. You typically have these long spells of very settled weather. So it's very, very nice to be up there. But in terms of the climate change aspect, sort of the one comment I'd say there, it's the kind of work that the survey is doing and other surveys around the world in conducting this geological mapping to produce these bedrock maps, which is actually going to be really important moving forwards to help with sort of developing green technologies, because for these green technologies, we need, for example, rare earth elements. And for these rare earth elements, we have to identify, for example, the alkaline igneous rocks that someone asked about earlier. So by understanding in detail sort of the nature of the bedrocks and where they are, and we might be able to understand some of the solutions to, stopping some of the more damaging effects of climate change through green technologies. There's certainly a great role to play for understanding geology. So it's not just this backward-looking subject, but we can actually be sort of proactive in supporting the future of the Earth as well then.
Fantastic. Well, thank you for that. And thank you so much both to Owen and Marc and everybody that's tuned in. Claire, are you around? Did you want to just provide some closing thoughts?
Yes, so I just wanted to say thank you to yourself, Matthew, James, Marc and Owen for coming on this evening, afternoon, depending on where you are in the world, and presenting on the Northwest Passage. I hope everyone's enjoyed the talk, and if you've got there will be a follow-up email to everybody that will be going out today with the recording of the session, and also we'll see about all the questions that we haven't necessarily answered this evening about whether we can get those sent out as well. And of course, if you've got any questions about the tour itself, please feel free to email me, or you can email Adventure Canada directly. All the information is on our website, and again, that will be included in the email that will be coming out to you shortly. I believe it's scheduled for Wednesday, so please keep an eye on your inboxes. So for now, just want to thank everybody and wish everyone a good night and a good evening or a good afternoon. And hopefully we'll see you at the next event, which is on the 12th of May. And that is about Rudyard Kipling and how his inspiration in Indian culture started, how he wrote the Jungle Book. So that should be an interesting talk as well. So thank you, everybody.